Right. So FRQ1 is a pretty typical FRQ question where you have three functions. One is represented as a graph, and then two of these are represented in algebraic form. And then you have to answer questions about them. So as you do it, just make sure you're looking at the right function, how it's labeled. So on A, we're going to find k prime of 0, where k is f of x times g of x. So what I would do first, if I was you on A, is just write out the product rule. So if k of x is f times g, the derivative of k is going to be the product rule, where we'll leave f alone, multiply by the derivative of g, plus leave g alone, and then multiply by the derivative of f, right? And then the next thing you would want to do is go back, since we're doing k prime of 0, is put 0 in for all of the x's. All right, and then don't forget that this is a calculator question. So you guys don't know how to find the derivative of g yet. Now, there is a way to do it by hand, but you haven't learned it yet. And even if you did know how, if this is a calculator question, then you still don't want to waste time doing derivatives by hand. So what we're going to do, we can find f of 0 just from the table or from the graph. So when x is 0, f is 3. But g prime of 0, we're going to do in the calculator. All right, so what we'll want to do is go to y equals and type in the g function. And especially, this is a good idea because we're going to use this g function multiple times in this problem. All right, so now when we're on the home screen where you do second mode, this is the home screen. Anytime we write y1, it's going to be that function. And so the steps are to do alpha window and choose number 3. All right, our variable that we're dealing with is x. Our function we stored in y1. So to get y1, we do alpha trace, and then that first one is y1. And we want to find this derivative when x is 0. Right? Now, I'm going to write all of those decimal, maybe not all of them. We're going to go all the way to this 3, because whenever I get my final answer, I want to be accurate to 3 decimal places. So I'm going to put in most of those decimal points. All right, g of 0, I can also get from the calculator. One thing I don't know if I showed you, you can go to the table and get g of 0 that way. It'll be that value. If you want to get it to more decimal points from the home screen, you can choose y1. That's technically g, and then put 0 in parentheses. So that's saying g of 0. And it'll give you a few more decimal places. It looks like the square root of 2 probably is, but that's okay. Yeah, it is, because if you did that by hand, those x's would become 0, and that would be the square root of 0. All right, the last thing we need is f prime of 0. And f prime of 0 is the slope of the line when x is 0. So this whole part right here, that has a slope of up, 2, right, 1. So that's the slope of 2. That means f prime of 0 is 2. All right, and then you can just type that straight in the calculator. And if you didn't want to round, you could go back up and choose these numbers. So let me show you. You could do 3 and then open up parentheses and then go up and choose that. And then close the parentheses. And then plus, go up and choose that. And then multiply that by 2. That way we're technically given the exact answer, or as close to the exact answer as possible. Now we want to be accurate to 3 decimal places, which means we can truncate and just do those 3, or we could round. Both answers will give you full credit. So your options are to say k prime of 0 is 1.767, or you could 1.768. Both are perfect. Now, if you want to get full credit for that question, you would want to show all those things. You can't just do it in your head and expect to get full credit. So make sure you show me all the things. All right, and then for B, the question is we have a new function m, and it's found by f of x over 2g of x, and we want to find m prime of 5. So I would start off and just do m prime of x. Now this one is a little tricky because you have that 2 on the bottom. So when we do the derivative of the low, it's just going to be 2 times the derivative of g because of the multiple of a constant. All right, so it's going to be low d high minus high d low. So like I said, that's going to be 2 times the derivative of g, and then over low squared. All right, and then I wouldn't really worry about simplifying anything for my next step. I would just go ahead and put 5 in for x. All right, and then we're going to go through the same process we just did. All right, we have g in the calculator, so to find g of 5, I can just do alpha trace and then choose y1 and then put 5 in parentheses. So that's saying g of 5 is that decimal. All right, the next thing I need is f prime of 5. So f prime of 5 is going to be the slope of f when x is 5. So it's the slope of this line right here, because x is 5 here. And that slope is down 1, right, whoa, just kidding. That slope is down 2, right 3. So negative 2/3 is that slope. All right, f of 5 is the value of the function when x is 5. So that is going to be 5. All right, and then g prime of 5, we're going to need our calculator to do that. I'm going to clear out some of this because it's a lot. Okay, so alpha window derivative number 3, and then our variable is x. Our function is in y1, and this time we want it when x is 5. All right, so I'm just jotting down that to a lot of decimal places actually. All right. And then on the denominator, I have 2 times g of 5, which we already have g of 5. All right, and you would need to write all that down. Then finally, I would type all that in the calculator. Okay, so to get the fraction, I'm going to do alpha y equals. Let's see if I can go back up and pick some things that I cleared. So 2 times in this is going to be that 4 point, that one. All right, and then pick the 0.91. Right, and then I'm going to pick the 4.1 again. Ah, shoot. Doesn't look like I can do that. I can confuse the calculator. Sorry, I'll just type it in. Okay, and then finally make sure it's close, outside squared. There's lots of places to make a mistake here. I feel like it's a miracle that I didn't make a mistake. So definitely show me all your steps, because if you just type this in the calculator wrong, the only thing you would miss is the very last point. This would be, I think, like a 3-point question. So you get a point for one of these two, probably a point for this, and then a point for the answer. So definitely show as much work as you can, because if you just make a mistake on that very last step, you're not going to miss a whole lot. All right, let's look at C. We want to find the value A and B that make h of x differentiable everywhere if possible. Okay, so to be differentiable everywhere, the function must be continuous everywhere. So the only number that would be an issue would be 1. So for the continuous part, we want the limit as x approaches 1 from the left of h of x to equal the limit as x approaches 1 from the right of h of x. And to do that, we would just plug 1 in for all the x's. So the left side, we plug in for that piece. The right side, we plug 1 into that piece. And then simplify it down. Now I am going to go ahead and get the A and B all on one side because I kind of know how this problem is going to work out. So I would move the B over with the A, and I would move the 1 over with the 3. All right, we would also want to take a second to double check that you do have an or equal to bar. So H of 1 is defined right here, so we're good. I probably should have done that first. Okay, the second part of showing differentiability is showing the slopes are the same from each side, so from the left and from the right. So I'm just going to go ahead and take that h function and find the derivatives. So don't forget that a and b here stand for constants. So we're not going to have to do any kind of product rule here. So think of a like it could be a 2 or it could be a 5. So think of it that way. So the derivative of the first piece, we're going to do the power rule here. So it would be 4x, and then the derivative of ax would just be a, and the derivative of -1 would be 0. All right, for the second piece, we're going to do the power rule. So it would be 3b a squared plus 2x, and then that one would be 0. So we need to show that the limit of h prime of x as x approaches 1 from the left equals the limit of h prime of x as x approaches 1 from the right. All right, so we're plugging 1 in for x. Okay, and then same thing, I'm going to get my b over with the a and my 4 over with the 2. Okay, now I'm going to take those two equations and I'm going to solve the system of equations. Now this one is definitely easiest to do by elimination, or I think it's also called linear combination, where you notice that A is basically the same. So if I subtract those, then A's will be eliminated. So when I do subtract, that becomes a negative, that becomes a positive, that becomes a positive. And I'm going to get 2b equals 4, so b is equal to 2. And then I can take that and put it here, or I could put it here. It's a little easier to do in the first one. So a minus 2 equals 2, so a is equal to 4. Okay, so that's how you do the free response question number 1.